All right. Hello, everybody, and welcome to the stream. Getting a little bit of a head start tonight. I'm going to start a few minutes early. Just going to do that in some hopes that we're going to finally finalize this render graph tonight, at least for now, right? So the idea here is that we are basically going to wrap up the implementation of this, clean out all of our old view logic, and possibly even get back to setting up our editor tonight. I will also mention that there's probably going to be some offline stuff that's going to be done as well in between now and probably the next stream or not. I'm not 100% sure, but we'll see how far we get tonight. Before I jump into things too much, I just want to take a quick second and thank the supporters of the channel, starting with the partners. They are the top tier of support on Patreon and YouTube memberships, and they are AR Slia, Gerboles Inc., and Patrick Kuhlman. I'd also like to thank all the other supporters listed here on the screen. They are the other tiers of support on Patreon, YouTube memberships, and of course, Twitch subs. Thank you all for your support. I greatly appreciate it. In addition, I also want to thank everybody viewing this on Twitch who interact with me here live, and or those of you who catch this on YouTube after the fact in the archives. I appreciate all of you guys being here, and of course, without you guys, none of this would be possible. So thank you for that. Smudge, good evening. How are you doing tonight? Welcome. So, like I mentioned, what we're going to be doing is we're going to be wrapping up the render graph tonight. And full disclosure, I actually have gone ahead and done some work offline in the interest of keeping things moving along. So if we take a look here, this is basically the list of files that I've modified. And I've actually got this up and running. And the reason that I did this is because we've already spent, I think it's either 4 or 5 videos or streams on this already, and I kind of want to move on, at least for right now. So I went ahead and did a little bit more troubleshooting and stuff offline. That way we could kind of get this in and move on. Okay. So what we'll do here is we'll just take a quick look at this diff. And so starting with engine C, we've actually removed this initial call in engine create to perform a resize because of the changes that are forthcoming in the rest of this diff. We don't actually have to do that anymore. And so that's been eliminated. In our engine run, we have actually relocated our resizing logic. For some reason, I had put that in, I think it was the update loop, or maybe it was the event callback. We'll see it here in a second. It was basically somewhere where it didn't belong. And I'm guessing it was probably because I was just plain tired that night where I was kind of putting that in place. So this has been moved to the correct location, and everything has been hooked up as it should be. So to recap, basically what we do is we check to see if we're currently resizing. We increment the number of frames since the last resizing call. And then we say if 30 frames have passed or greater since the last resizing event, we go ahead and actually perform the resize call. So here we actually call first to the renderer, passing the engine state width and height. We then call render frame prepare. And what this does is this is the function that actually examines the swap chain to see if it has to be if the swap chain actually needs to be regenerated, and starts the regeneration of that swap chain if so. So we actually have to do this here. And so this is actually, there's 2 different places where this could actually be called. So this is one of them. And then we'll get to the other here in a second. And then we notify the application itself of the resize. So after we've done the swap chain stuff that we need to do, we go ahead and we notify the application of the resize. This then passes that on to the render graph. Because the application owns the render graph, the application should be responsible for telling the render graph that a resize is required. So that is what happens here. And then, of course, we reset the flags for the resizing and then the frame since resize. Let's see. Smudge, doing reasonably well. Had a hell of a time sorting out some concert tickets that came in wrong. Oh, that's always fun. Especially since some of those companies will be on hold for like 4 hours trying to get somebody. Coffee, welcome. How's it going? Good to see you. And yes, I did finally actually fix the bot command that detects coffee in chat. So every time somebody types coffee in chat, it says somebody drank a coffee, and it keeps track of how many times that's happened. So that's finally fixed. Anyway, so back to this. Basically, if we have not surpassed 30 frames since the last resize event, then we go ahead and we skip rendering the frame, and we just we basically sleep, right? So we're basically faking doing some work here. And this is just because we don't need to be running this in a super tight loop if we're not actually handling this as we should be, right? And so this basically will, at 60 frames per second, we'll essentially wait half a second for frame resize, which I think is reasonable. Okay, so in either instance, if we are in the resizing logic whatsoever, we are going to skip the frame and try again on the next frame, right? There's no point in trying to start render passes or any of that kind of stuff. If we are within resizing, we're not going to try and draw at all. We're just going to continue on to the next loop. All right, the next thing is after this check for resizing, right? If we haven't continued. That means that no resizing is currently taking place or none of that stuff is required. We then go ahead and prepare the frame, which again also verifies that the swap chain is good to go. This also verifies that various render flags have not been set, or if they have been set, that maybe the swap chain needs to be recreated. And so, like I have vsync in here in the comments as an example of that, right? And so, in this case, if this returns false, then that means we should not render the frame, but we should go ahead and notify the application that a resize event has happened. So the reason that we'd want to do this is because, again, the application's resize event is tied to the render graph or render graphs that it owns, right? And so those things need to be notified anytime the swap chain is changed. Reason for that is because anytime you regenerate the swap chain, you get new swap chain images. So the pointers to those render targets have to be updated. And so this is how all those updates actually make it in. Ruche, you had a coffee too? Coffee. I would have some coffee now if it didn't keep me up all night, honestly. All right, so the next thing that we have here is if for some reason the engine fails to prepare a frame, we're not going to throw an error about that anymore. We're just going to go ahead and skip the frame, right? We don't really need to be throwing an error there, so we've just removed that. And then this is where the resizing logic had been put, was in the resized event handler, which is not right? Because that doesn't handle like frames and stuff like that. So this was put here by mistake. It's been removed. Okay, so the next file is our renderer front end, which only has one change. And that is in the renderer on resized, we basically just reach out to the plugin and call resized. This was done in kind of a funky way through the engine before, and now it's being handled by the renderer front end like it should be. Okay, so our our regenerate render targets function has had a slight update. So before it took Rendergraph and Rendergraph pass, and now it takes a width and a height. So this is called anytime we have a resize event, right? And that's how we know what resolution to generate the new render targets at, right? In addition, when we have a render graph destroy, we were not destroying the resources that were occupied by that render graph pass. So in this case, what we do is we destroy all the render passes, right, that are associated with that render graph, right? So we go through each one, we destroy the render targets, and then we make sure to free up those internal resources as well. So we get rid of all that stuff, and then we actually destroy the pass itself, right? So that's that. So in Rendergraph finalize, all we do is we pass a default resolution into regenerate render targets when we are finalizing, right? Before, this didn't have a resolution. Now we're just using a default one. I marked this with a to-do because we should probably be getting the default resolution rather than hard coding this stuff, but I'll come back to it in the future, right? It's not a huge deal. So the render graph on resize, we just changed the width and height parameters to U16s instead of F32s because U16s are, they make more sense for like an image attachment, right? We're not gonna be working in partial pixels here. So we've just gone ahead and made that change and then passed those through to regenerate render targets. Regenerate render targets, of course, we have the function signature update here as well. And then instead of just using the first attachment's texture width, we just pass the width and the height that are passed in here to handle that. And that'll be correct going forward. Okay, so the next thing is this is the header file. So this just reflects the change that we made in the implementation file. So we just changed from floats to U16s. The next change that we have is in our game state, right? So this is in our testbed lib in our game state. And we've added the render mode here, right? Because when we moved all this stuff around, the render mode logic actually wound up getting kind of lost. So before, the world view is what was responsible for maintaining this render mode, right? And it just kind of received a message and changed that state and maintained that state within itself. It makes a lot more sense, I think, for the application to actually manage that. So we've moved that to the application. So the other thing that I noticed was the passes themselves. So actually, let me go down a little bit further here. So the passes themselves, the editor pass, the scene pass, and the skybox pass, and the UI pass as well, a little bit further down. They were not destroying their render passes. So we've gone ahead and done that, right? So those have just been added to the destroys. And then a little bit further down, the UI pass, we did the same thing, but we also fixed a bug when drawing the bitmap text. We initially had an array of just pointers for the ext data texts. And so we were grabbing the address of data text sub I. And we've changed that to a double pointer or an array of pointers, right? Because this extended data doesn't actually own the UI texts, right? We should be maintaining pointers to those things, not the actual objects, right? So we see the other half of that change here. In our UI pass extended data, we now have an array of pointers here, right? We've also made some changes within the simple scene. So when we're when we're performing the render data query, we're not setting up these objects unless we actually have debug geometries, right? There's no sense in doing this unless we actually have this, right? So we've moved this into here, right? And then we just go ahead and set that up in the debug geometries array, right? Likewise, we've done the same thing with directional light. So that's all this is we're just basically taking all that logic that was outside of this check and moving it to inside, right? Nothing crazy there. Same thing with this guy here for point lights, right? So the same thing with all the point lights. We're just moving them inside that if check. And then same thing here with let's see, these are our debug box 3Ds, right? So we're just moving that inside that check as well. And that's all that is. In the testbed main, we have added something to game on event. So this is where we handle the set render mode code, right? And so we've moved this from the world view to here. And all this does is just set the state render mode to the appropriate mode all the way down, right? Pretty straightforward stuff. Next is, let's see, in the prepare frame, we actually just changed this to a return of false instead of return true if we're not running, right? Because this should indicate some sort of an error if we are calling this function and we're not actually running, right? Like that's not right. In addition to that, we have added some more data to each pass as we're gathering the data for that. So this is basically what that is. Let me just catch up with chat real quick here. Jodaba, first time chat. I hope I pronounced that right, but welcome. Click because the thumbnail in Thor's Discord looked like Edward Snowden's cousin. Staying because interesting and educational engine dev stream. I think that's the first time I've ever gotten that. I've been told I look like a lot of different people, but that's definitely a first. But welcome. I'm glad you're here. All right, so basically this is in the data gathering section of our render graph, right? So all we're doing here is we're basically setting up the pass data. We're flipping the do execute to true for this is the scene pass, right? So we've already done this for the skybox pass. We're just implementing the scene pass now. And so we get the camera, we get the viewport, view matrix position, projection matrix, all that stuff. Ambient color, which I do have a to-do here still to get that from the scene. The scene doesn't actually hold that yet. It probably should. And so this should probably pull from state main scene ambient color, but we don't actually have that. And I figured this pull request is going to be big enough that we probably shouldn't add it here. We also set the render mode that's passed through directly from the state render mode, right? So we just gather that data up and get ready to fire that off to the render graph. So the other thing here is within the prepare frame for that same pass, I was zeroing out the terrain geometries when it should have been the terrain geometry count. So it's basically creating an array and then instantly like nuking the reference to it, which is terrible. So that was a bug. It fixed that. The editor pass is basically the same thing as our scene pass, right? We just we flag it to be true. In other words, that we do want to execute it if a scene's loaded. We set up the viewport, view matrix, position, projection matrix, right? The other thing that we do is we changed our logic for the texts to also use our allocator correctly. This is an array of UI text pointers now, right? So we just reserve some space here, and then we go ahead and push these onto there. These are the two test objects that show up on the main screen, and then if we have a debug console, we add those as well. And we're almost done. So we've removed the renderer frame prepare out of application render frame because it didn't really belong here anyways. And so the engine is now responsible for calling this. Otherwise, we've changed our call to Rendergraph on resize to just take in the state, width, and height instead of just passing them through as we were before. And then when we actually shut down the application, we destroy the render graph to make sure that we kick off destroying all those render passes and all of the attachments and all of those resources that we've actually gathered up, right? So this just kicks all that off. And then a little bit further down, we have the event registration and unregistration for the event code to set the renderer mode. So nothing really new there. We've just kind of moved it. This was a formatting change. This is a formatting change. This is a formatting change. This, we actually zeroed out the array because I noticed that there was some rubbish in here because it was uninitialized memory. And then this is a formatting change, and this is a formatting change. So that is the summary of the changes. It's actually not all that much stuff that was done, right? But it gets us to a point where we can actually run the thing correctly. So I guess let me do a build clean, right, and a debug build. Let's go for unique first chat. I'll take it. Awesome. Yeah, that is pretty unique chat for sure. All right, so now we can go ahead and run. I've also been experimenting with a different debugger, yet a different one than even you suggested, Kohi. So I've basically gone back to using nvim-dap, but I've changed my my setup a little bit. So it works a little bit better than it did last time I tried this. And the reason I stuck with this one is because it's just a lot nicer to be able to set your breakpoints right in the buffer, as opposed to like having to open another application, open the code file, and set it there. Okay, so here we are. So this is our testbed running with the new Rendergraph. So if I load up a scene, I'm going to need to change that viewport so we can actually you know, make sense of what's going on in the scene, use the whole screen. But we can see that you know, this seems to work, right? So anyway, oh, it looks like, wait a minute, I clicked on the screen, so that looks like we might have found something else. D-array resized called an array with 0 capacity. This should not be possible. That's pretty cool. So what happened is I clicked in the scene and did a raycast. It looks like the raycast actually succeeded. So this is where we broke here. That is interesting. So this is where we're pushing debug geometries. Is that... So why did we... So this is actually something I haven't tested yet, which is interesting that we've hit this bug. So... I'm thinking... This is pushing into debug geometries. Did we actually set? I thought we did. Add terrains, debug geometry. Oh, that is interesting. So I was trying to get around using a D-array for this because we already knew from this call how much we actually needed to, how much memory we actually needed, right? But what I didn't take into account is that we actually need to add to this later. So what I will have to do is convert that to a D array, I suppose, and then update its capacity after we do this, and then push to it, I think is going to be the way that's going to go. All right, so let's stop this. And you know what? I'm actually going to get rid of that pane. And instead of this, I'm going to say darray reserve with allocator. We're going to use our frame allocator for this. So this is going to be geometry render data. Geometry render data. And then the count that we want is going to be ext data debug geometry count. And then we want to use the, actually I think we already have the allocator address here. So I think we can get rid of all of this. Oh, we don't. Okay. So we want the address of pframe data allocator. Okay. And so that means that we'll have this amount reserved. Let me see something here. So I believe this just sets length to 0. So we're actually going to have to set the length manually, right? So this is just reserving the memory for that to allow us to sort of insert these things as if it were just an array that was allocated like what we had before. So now we're going to have to say darray length set, and then ext data debug geometries, and then the value is also going to be ext data debug geometry count, right? Make sure the count is correct before pushing. Okay. Now when we do this stuff down here, we should be good to go because we just push into that same array and we should be good. So build that. And load up a scene. And I'll try clicking again. And now we're good to go. So it looks like our raycasting is working again. We can see our raycast points there, right? So that all seems to be working. Do our misses work as well? Yep, so that's what the magenta lines are there. So yeah, we have our object selection, I believe, also should be fine. Yep. So our render graph is in and working as expected, which is awesome. And we shouldn't have anything having to do with our old view system being called at all anymore, which is pretty sweet. All right, let me just check up here. Philip, hello, welcome. Engine widgets, yes. Gizmos, all those good things. So yeah, we've just actually finished up the implementation of our render graph, which is pretty sweet. So I think what I'm going to do is I'm going to commit this code as is, and then I'm going to go through and remove all of the view stuff and have that be a separate commit, and I'll push all this up to the branch. Custom array struct, yeah. Yeah, there's... Are you talking about, like, these guys? Bitewave, welcome. Congrats. Thanks. Cool. Looks like we have ads starting here in just a second. I think in a minute or so. So I'm going to go ahead and just commit this now. And then when ads are going, you guys won't be missing anything. So we're already on the Rendergraph branch. Saved everything, I think. All right. So get commit Rendergraph application complete. All right. Oh, did I not? Why is it complaining about the... Yeah, I know bin is ignored. Why is it warning me about that? That's weird. Okay. Oh, ads. All right, and we're back. So that error I was getting from Git was literally basically just telling me I'm an idiot, which is fine because it was right. It was because I was in the bin folder instead of the actual root folder, which is fun. All right, so git status. All right, git push. All right, so that code is available in the repo. And so what we're going to do now is we're actually going to use the file browser for this because I think it's going to be a little bit easier. And we're going to go into, let's see, where did we have those? I don't know if any of them were in the engine still. No. We did have systems in here. So render a view system, those are going to go. We can delete that one. So we don't need the render a view system anymore. It's gone. I think that's all that has to be removed out of there, I believe. Testbed lib, I think, holds everything else that we need. So, yeah, so we have a couple of views in here. Which actually, so this one can go. And this one can go. This I need to hold on to for a little bit because I actually need to re-implement that wireframe view as a wireframe pass. So I need to hang on to that guy. And then views. I'm going to remove this one, this one, this one, and this one. And then this pick, I actually need to implement that as two separate passes. So I need to hold on to that for a little bit long as well. We are back. Yes. And incidentally, in case you guys are wondering or you're new to the stream or whatnot, this is an interactive stream. So if you guys have questions or whatnot, or comments, or just want to chat, feel free to drop it into chat, and I keep an eye on that. So will you use some kind of colored buffer to pick objects? So yes, that's actually what we do. And so I don't have that pass currently active right now because I have to reactivate it. But yeah, everything that's pickable has a unique identifier, and I use that identifier to generate a unique color. And then we basically just, render everything onto the screen that's a slightly different color. And then when I click, I say, what's the color of the pixel at this location? And then I can translate that backwards into an integer, which gives me that ID, which gives me the object. So we have that form of picking, and then we also have raycast picking, which I use to pick objects in the scene, right? And so we actually have two different methods of picking, but the picking that we have here in this render view will no longer work because we don't actually have a render view system to work with, right? So I have to convert that to a pass, and I don't really think that's worth doing on stream, right? Because we kind of walk through the whole process of how that works. Same with the wireframe view, and we've kind of gone over that already. So like, I don't really want to re-implement that on stream. I could do that off camera and then show you guys afterwards. Any idea for transparent 2? What do you mean by that? You mean like picking transparent objects? Because if you're talking, yeah, for picking. So when it comes to picking, translucency doesn't matter, right? So if you have, if something is even remotely like there in terms of translucency, I just render it as opaque. So it's an opaque color. So literally what you get in the pick, what I call the pick pass, is you just get a flat solid color. Yeah. So it doesn't take in lighting into account. It doesn't take transparency into account. It's literally just rendered as a solid color, and then that's what we pick from. So yeah, transparency doesn't actually matter. If you're asking, like, can you pick an object by going between the leaves of a tree when the leaves of a tree are like on a texture and it's 100% transparent? No, I'm not going to do that. It's not worth the extra computing power to load the textures in and then render it. Like, it's just not worth it. Yeah. You wouldn't get much gain out of doing that. If we could add it, I suppose, maybe as an option, but yeah, it's not generally worth it. LSR, hello, welcome. How are you? Hope everything is going well. All right. So I think what I'm going to do, so we have all of our passes here, our views. Let me rename this to views deprecated. And I'm going to take this and put it here, and this and put it here, right? And then we know everything under here is going to be deprecated and it's not really used. In fact, I wonder actually if this is going to even build. Probably going to have to clean first. Nope. Yeah, that's not terribly surprising. Oh wait, that's the renderer front end. I can fix that one. So yeah, let's get rid of that guy. Simple scene. Simple scene, use that? Really? In the header file, use that? What? Why did I have that? That's very strange. I don't know why I would have included that there, but okay. Testbed main, I'm not surprised about that one. Yeah, so we can get rid of that. Don't need that. Simple scene.c. I thought I already did that. Apparently not. Oh, the views are going to rely on that too. So actually, the render graph is actually done for now. So what I'm doing right now is I'm removing all the render view stuff. We actually just finished up the render graph here a few minutes ago. And that's actually already committed and pushed up. And so what I'm doing is I'm also removing all the legacy view stuff. But there are a couple of views I need to hold on to in this views deprecated folder. And that's because it's the pick and wireframe views that I have not converted to passes yet. So I have to hold on to them, but they're causing errors, which is going to be an issue. And I don't know if I'm actually going to be able to get these to build. Wireframe, okay. Let's see if that builds. Be neat if it did, but I don't think it's going to. Undeclared function, yep. Render targets regenerate. Line 58, okay. So, I mean, I don't need that anyway, so I can just comment that out. Looks like the pick also has that. Cool. All right, that was actually a little bit easier than I thought it was going to be. So just for good measure, let me clean and build again, just to make sure everything works as expected. All right, I think we are good. So here's all the stuff we're deleting. Deleting a lot of code now. Some of this is moves. So the pick and wireframes are moves, but everything else, all the other deletes here are legit. Okay. So git add, git commit, removed render view system. Deprecated, I guess I can say pick and wireframe views, but leaving in place for now. All right, so that's that. All right, we'll push that. And now, I'm going to open up a good old pull request. So we want the Rendergraph branch. So we have 9 commits, 37 files changed. Yeah, this is a big boy, as you can see by the size of my scroll bar over here. So this is all the work that goes into our render graph, right? Now this also includes deletion of files, and I think those are actually collapsed in here. And some of the larger diffs are actually hidden. Like, see, these are default. So like this isn't even really an accurate representation. So we have 2219 additions and 1796 deletions. So we net gained a little bit of code, but also, well, I can't even say that because deletions aren't necessarily lines of code, right? Deletions and additions aren't lines of code. So I think we actually wind up with less code. Anyway. Oh, what a dingus. Why am I not signed in? Hold on a second. I updated Arch earlier today, and like part of that upgrade was GitHub, and it has been logging me out of everything. See if I can remember my dingus password. Multi-factor authentication, it's always fun. Bear with me 1 second. Why are you not showing me the... Why are you not giving me the dang... Alright, I guess I'm gonna have to use the... authenticator, annoyingly. There we go. Sorry about that. All right. So we can create the pull request. And I'm going to go ahead and merge it. And we'll nuke the branch. All right, so the render graph is available for you guys to pull on the main branch now. Friggin' sweet. Cool. All right. Quick question. Do you know of any tools on Linux apart from RenderDoc to debug GPU? RenderDoc is what I use. You could also use NVIDIA's tool to do that. What is the... The name escapes me at the moment. Let me ask Google Sensei. Insight. NVIDIA Insight is another one. And they do have a Linux version of that. So that's another thing you could use. I just stick with RenderDoc though. The only thing about RenderDoc is it doesn't work on Wayland. So if you're using Wayland, you're kind of stuck, but I actually don't know if NVIDIA Insight works on Wayland either. So you might be stuck as far as that goes. But like, as far as I'm concerned, like if you have to use Wayland, like it all goes through X Wayland anyways. So yeah, I'm still on X right now. Like I do have, when I'm using Hyperland as my windowing system as opposed to Cinnamon, which is what I'm using right now, then I'm on Wayland, but I had too many annoying issues on that with graphics programs. I don't think GPU capture programs will really help you debug presentation. Well, that depends on what you mean by presentation. You mean like while you're getting weird artifacts and stuff? I mean, yeah, it can help for sure. You can see what data you're sending to the GPU, so it absolutely can help from that perspective. Use AMD or NVIDIA? I use NVIDIA. But it's recently come to my attention that there are some things that AMD cards can't do that NVIDIA cards do. So at some point, I'm going to have to wind up getting an AMD card to troubleshoot with. And I haven't exactly figured out how I'm going to work that yet, because I can only imagine what having two GPUs in the same machine with like rivaling drivers is going to try and do to it. So I'm probably going to have to like set it up so that I use, I don't know, one GPU on one installation and another on a different installation or something. I'm not sure. So I've got some stuff to figure out there. For presentation, you mean frame pacing and presenting the final back buffer to the compositor? Yeah, so I don't think it's going to be useful in that regard now. Because that's really like OS level stuff. That's outside of kind of what the graphics driver is doing. I mean, at a Vulkan level, or like a graphics API level. Dedicating a GPU specifically to a VM is totally possible. True, I haven't tried it though. So that might be the way that I go about it, but like you still have to have it installed on the host, right? So like how would the host machine deal with having an AMD card and an NVIDIA card on the same installation? I don't know. Like I get what you're saying, Smudge, but I just wonder about how that's going to work on the host. You can even do GPU virtualization on a Windows guest. Yes, you can, but again, you can't emulate. What I would really need is an emulator, which doesn't really exist, unfortunately. So somebody actually presented some really weird behavior that the Mesa drivers are actually doing on an AMD card, and I actually was able to reproduce similar behavior on an NVIDIA card, but it wasn't exactly the same. And on my NVIDIA card, it works, and on their AMD card, it crashes. So it's like stuff like that. Yeah, so that would be the ability to ignore one GPU on startup would be what I need. I've literally not looked into it at all. So if I could figure out how to do that, how to like select a GPU on startup, then that would be the way to go, 100%. Although, again, you'd still have two sets of drivers sitting on the machine, so I don't know if they would sort of try and clobber one another or not. It'd be interesting. I probably would not try it on my main installation. Last thing I need to do is brick that, right? Okay. So, one thing that I did want to do is I wanted to show you guys something, actually, that I was kind of working on before. Let me bring something up real quick. Let's see, I think that was under... Okay, so why does that not work? I had it running earlier today. I'm trying to run VTune, and I actually had it running earlier on my machine. But now it's not wanting to launch for some reason. Oh, I see the problem. There we go. All right. So, one thing that I thought was kind of an interesting thing to take a look at. I don't even think actually I have to rerun this because I think it actually saved my analysis. Yes. So I ran some profiling on Kohi earlier today, just to see kind of what we were dealing with, right? So I basically let it run for like a minute and a half or something like that. Yeah, a little less. No, a little more actually, depending on, I guess, where you count the start, right? So this is the startup of the engine, right? So this is initializing all the systems and all that stuff. This is where all the job threads are started up. So these are all the job threads right here. And then this is kind of where the rendering stuff was kicked off. And then right in through here was basically like an idle time. And then here is where I triggered the scene load. So you can see all of these jobs being triggered on different threads, right? And then after this, we have a pretty decent load in terms of rendering, right? So I was kind of trying to figure out like some things that we could look at in terms of like upping our frame rate. And I was actually pretty surprised at what I found. So if we dig into here, we can see like the CPU total time overall, right? It's kind of like a running average, right? Which this one I'm actually not sure what it is. I have a feeling I know which one that might be, but I don't know 100% sure. But I was looking through here in our engine run, right? And in our application update and render frame, obviously those are the two heaviest, right? Which makes sense. But if I look at application update, it looks like simple scene update and UI text set, right, are taking up the biggest percentage of CPU speed, right? Like everything else is negligible. So if I drill a little bit further into this, it's like, oh, box 3D color set. Remember I said this was going to be slow? This is because we're basically just updating the vertex data on every frame, which is fine. But the problem with this is when we do the vertex update, we use let me drill into this a little bit further. We use this load range. And load range uses a temporary buffer, right? So it actually it creates and destroys a staging buffer every single time. Coffee. VTune Pog. Yeah, so this was something that I did as like a temporary like hack and completely forgot about and completely forgot to address. So basically anytime we load a range, it's creating a new staging buffer, using it, like binding it and all that crap, and then destroying it. Yeah, it was just a temp thing. And I totally forgot about it. And I'm like, man, what is... Like, my frame rate should definitely be higher than this. And that's definitely, like... Definitely a big one. So, I'm thinking about maybe we can take a look at that tonight and see where we get with that. There are some things around that we kind of need to think about, though. Because this... create and destroy pattern makes everything very linear top to bottom, but it also comes with, it solves some problems that we're going to have if we try to reuse the same one, right? So we'll jump into that. So the extent set doesn't really do anything, but the color set absolutely does, right? So there's that, and then the UI text set. When we regenerate the geometry, in other words, the text is changed and we have to regenerate all those quads that we actually blit the fonts onto and whatnot. Guess what we call load range. Guess what that does? Creates and destroys a buffer. And that bad boy is running at least once a frame, I think. Yeah, at least once a frame, because every frame we're reevaluating that UI text that's up on the screen. So unless the text hasn't changed between one frame and another, we're redoing that every single frame, which is it's awesome, right? Nothing's more permanent than a temporary fix that works. It works, yes, but it's rubbish. Ads. And we're back. So, laughing my ass off, you said it's rubbish, and then instantly got an ad that said, "What if I told you it's not?" I love juxtapositions like that. That's amazing. Let's see. I was wondering about that too. Is it when you need to map a descriptor? I was wondering if a buffer should stay mapped instead of mapping stage unmapped. Yeah, so generally speaking, whenever you map a buffer, it should stay mapped, right? There's no reason to be constantly mapping and unmapping a buffer. The only time you need to unmap it is when you're getting ready to destroy it. And so, yeah, what we're doing with the staging buffer is really bad, right? So we probably should go ahead and fix that. Cool. So I guess let's kind of jump in and just have a look at that and see where we wind up with it. So this is going to be definitely in the back end. So here we are. So I think we do this in a couple places, if I remember correctly. We could actually probably just search for render buffer type staging. So there's the enumeration for it. Okay, so there's one place that we're doing it. This is just when we're creating it as to what memory flags to use. Okay, so there's two places that we're actually doing it. So one's for a texture write, and the other is for load range. So I'm going to focus on load range first, because that is the one that we're primarily using. Texture write, I don't even know if we're actually... I think the only time we're using texture write Actually, I don't think we're using that at all yet. We're only using texture read, I think. Well, let's see. I assume even unmapping and remapping permanent staging buffer would be faster than creating and destroying one every time. Yeah, it would be. Although you still wouldn't really want to do it. That makes sense. If you unmap if you really dispose a material of something. You need to have that fixed too. Yeah. Yeah, so we're not going to... and actually... So let's see. Let's just review what we did here, because I wrote this stuff a long time ago, right? So we create the staging buffer. We bind it. Then we load a range. So we're loading from the raw data into the staging buffer. Then we copy from the staging buffer to the local buffer. And then we unbind the buffer and destroy it. Okay. So the nice part about the way that this works is you'll notice here that we can say, like for our render buffer bind, we have an offset that we can pass, right? Our load range, so the offset here and the offset in the load range is 0. They're all 0 based. It's also the copy from the staging buffer is 0 based, right? So technically speaking, all three of these numbers, these zeros, would all be the same, but we're going to have to essentially keep a running tally of where we are in that buffer for every frame, right? Because we're going to have multiples of these, and we're only going to be resetting or reusing this render buffer once per frame. But we're going to be using it multiple times per frame, so we can't just say 0 for everything, because we're going to be overwriting our data repeatedly, which also isn't good. And so probably what we need to do is we'll need to create a render buffer when we stand up the back end, right? We'll create a staging render buffer. We'll need to figure out how big that needs to be. And then we may need to maintain some sort of free list. Which is kind of like what our front end buffer does anyway. So we might actually be able to use some of our front end logic already to handle this. Because our render buffers can be created with a free list, right? We're not creating it with a free list right now. But we could. And we should. Because, yes, the free list incurs some overhead, but not as much as creating and destroying a buffer every single time. I don't get what's the 0 about. Okay, so so what this is basically saying is when we bind the buffer, we're saying, okay, where do we, at what point within the buffer are we binding, right? So this is basically saying bind from the beginning of the buffer. When we load the range, we're saying, okay, we want to load into the staging buffer starting at byte 0 this amount of data, and here's the data to load, right? And in this case, the Vulkan buffer copy range, we're saying, okay, copy from the staging buffer starting at 0 to our out buffer starting at a given offset, which is provided to us, and copy this size of data, right? And so we're just copying from one to another. So these zeros are hard-coded only because we're always starting at the beginning of this buffer because we create it every time. So we can't do that. Because we can have multiple things going into that buffer at once. So we just need to sort of create a running buffer, right? The other thing that I'm thinking is this copy range. Copy range internal. So this is kind of another thing we eventually need to fix. So this copy range is using our main graphics queue, which is kind of crappy as well. Right? We should probably have a dedicated queue for that. Oh, wait a minute. There's another issue here, too. So, I just found something else. So, wow, what did that just do? Okay. So it looks like we're allocating and beginning a single-use command buffer, which is probably not ideal either. We should probably be reusing the command buffer as well. So we wait for the queue to be idle. We start a command buffer in here. We do the copy command, and then we end the buffer and basically nuke it. So we may have to actually revisit this as well. That's, I'm not thinking, going to be quite as heavy as what we're doing with the actual VK buffer stuff, but that's not right either. Okay. So I guess probably the place to put this, because this notion of a staging buffer is kind of a Vulkan specific thing. I don't know if our other backends are going to require us to have one, so I think I'm going to store this on the back end, but use the front end render buffer type. So let's go to, I guess, Vulkan context. And we'll stick in a staging buffer there. A reusable staging buffer to transfer data from a resource to a GPU only buffer. All right. Let me see. Sudden death. Hi, fellow C developer. I like doing C a lot, but everyone is telling me that I won't be able to find any junior C jobs and I'm wasting my time. I still do C for fun and learn more about programming in general. What do you think about all this? So, it's a bit of a loaded question, and there's lots of unknowns, of course. I don't know what your goals are and whatnot. I can tell you from my own perspective, though, that it is much harder to find work out there just as a pure C developer, for sure. Even C++ is a little bit harder to find. Doesn't mean it's impossible, though. And so what I would recommend is, like, you skill up with something else like web development or something like that and get something that pays the bills and keep doing C on the side. And if something comes along that you can do C, great, jump on it. I myself do full-time web development during the day. So, that's what needs to be done to pay the bills, and I'm fine with that. C is my passion, but, it can't always necessarily be what you get paid to do, right? But that also being said, it is absolutely not a waste of time, because learning a lower level language like C helps you understand how the computer works a lot better, how memory works, and it'll help you understand some of the drawbacks and issues you'll run into with some of those higher level languages like C# and whatnot. And so it's absolutely not a waste of time. But maybe, keep learning it and keep doing it as a hobby, in your spare time and whatnot. But also focus on something that there is a lot of demand for so that you can get a job to pay the bills, right? I hope that makes sense. Meborn, hello, welcome. Okay. So I'm going to clear the highlights. I'm going to grab this and backend initialize. We should have up here, create our buffers. I don't remember exactly where this was, because again, I wrote this code quite a while ago. So this is just all our function pointers, swap chain, create command buffers. Let's see. Here we go. Here's our buffers. So we have our geometry vertex buffer, our geometry index buffer. Right? And so, let's see. Let's actually just go with hard-coded buffer name. So we're just going to call this staging. We're going to have one staging buffer that we're going to use for everything. The size gets a little bit weird. Staging buffer. So like, how do we know what size to make this? I could guess on a size, right? But I don't know that it's going to be correct. So it looks like our index buffer is 100 megabytes. Our vertex buffer is whatever that is. I can't do that in my head. So let's say const u64 staging buffer size, and we're going to say, let's go with 256 megs. I don't know that that's going to be enough, but staging buffer size. You can also update this message here. Okay. I don't know that we necessarily need to bind it. I don't see any reason to bind it right away. We'll bind it when we use it. Let's see. Thanks for the advice. I'm a junior web developer. I do Laravel Vue at work. What you said makes a lot of sense, really. Thanks. Yeah, no problem. Like I said, it's a perspective similar to my own, right? Like, I'd love to write C all day professionally, but those jobs are kind of hard to come by, right? Red.Andy, first time chat. Welcome. Welcome to the stream. Hello there. I've seen some of your YouTube videos, and the first ones you were on Windows. Just out of curiosity, I see you're using Linux. Have you fully switched, and for a specific reason? Yes, I have. And I've actually gone through a couple of different flavors of Linux. Right now I'm on Arch Linux, and I'm using Cinnamon as my desktop environment. But I also used Ubuntu for quite a while, a couple of years actually. And so when I went full-time Linux, that was... full-time Linux for me was probably about 2 years ago at this point, maybe a little bit more. And mainly because I just got kind of tired of all the loops you have to jump through on Windows to do stuff. Whereas in Linux, I can just do so much through the terminal. I can do almost everything through the terminal. And I really love that about it. And so, yeah, like I like being able to customize my operating system the way I want it. And this is a lot lighter than Windows is. It's a lot faster for me. It's a lot easier to work in. I just prefer it. So yeah, it's and the reason I switched to Arch is because Arch has always got like bleeding edge libraries for everything, right? Which sometimes means that it breaks too, but yeah. Arch user, easy, wine time, classy. Yeah, Arch, by the way. Yep. Yeah, I still do actually have an Ubuntu installation that I boot up like once every couple months. But yeah, I don't really ever use it anymore. I mainly use it like if I have to test something on Ubuntu versus Arch, then yeah. Smiling Big, welcome. First time chat. How are you? All right, so we're going to go with 256 megs for now for our staging buffer and see where that gets us. Shutdown, we're also going to need to destroy that. Do we actually... Where are our... Oh, here we go. So I just need to add render buffer, destroy, address of context, staging. All right. So that's that. Oh, I did say that I was going to use... I did say that I was going to use a free list, so I actually do want to change that to a true. Why is this on 2 lines? Right. Okay, so that should be all I have to do there. So texture write data. Okay, so this is our load range, so I'm going to get rid of this one first. For now, I'm going to comment that out. And we're going to... Where else? What am I doing for... What am I doing for the other buffers? Actually, I think once they're bound, I don't have to... Maybe I could just leave it bound. Suppose I could bind the whole buffer. That's the uniform buffer. You saw we also have a read buffer in there we're going to have to take care of as well. Here we go. Nope, that's not the right one. Yeah, here it is. Okay. So I guess I could just do... We'll just do that for right now. All right. And then type staging. Whoops. Type stage. All right, so I'm actually not sure if we even have to do this step or not. I don't think we do, but I'll do it anyway for now. Load range. So load range is actually, we're not going to be able to do that directly because we actually need to figure out where we need to load in the buffer. So we need render buffer allocate, right? And we need the address of context staging. And I think it's a position offset, I think it is. Too few arguments. What? Oh, buffer size, then offset. Okay. Buffer, and then size, then offset, right? So we have to allocate this first. So U64 staging offsets. Right, so we'll use the staging offset there. And then we should actually be able to say context staging offset. And then copy range is going to be the same thing. So that's going to be context staging offset, right? And then I'm thinking we can skip that and this can go away. So the only thing that's going to be an issue here is we have this allocate. Do we have a free all? So render. I don't remember if we actually did a, so load range, copy range. I don't think we have any way to wipe the entire buffer, which we actually kind of need. Surprised I didn't add that actually. Okay, so what we're doing here is we're saying, okay, we're calling this allocation routine. And this is going to say, okay, we need a block of memory this size, right? And give us what the offset is from the beginning of the buffer, right? And that gets saved to here. Then we can load that range using that offset and size, right, of the data. And then we copy from one buffer to the other using that same staging and offset. And that offset will just keep moving along, essentially, as we keep doing things within this frame. However, we need a way to reset that because we're going to quickly run out of memory if we don't actually like deallocate these things, right? So we obviously don't want to do that. We need to essentially reset that buffer at the beginning or the end of a frame. Probably the beginning. It's probably going to be the best place to do it. What's the actual data getting mapped? Is it all your material? So there's actually, it depends. So it could be texture data, it could be vertex data, it could be index data, it could be a whole lot of things, right? It could be any kind of data. It could be material data too, going into the uniform buffer, right? Like it could be anything. So the idea behind this is to not have it be strictly bound to different types of data. Yeah, anything. Yep. So we're trying to make our renderer as data agnostic as possible. Oh, stretch redeem. Just saw that. It's perfect time because ads are starting here in a minute anyway. So yeah, what we need to do is we need to add a render buffer clear, maybe? I could have swore we had that though. Resize. Yeah, so here's create, destroy, bind, unbind, map, unmap, flush, read, resize, allocate, free, load range, copy range, draw. We don't have it. So I guess instead of calling it free all, I could call it clear. Listening to your stuff makes me realize that there's stuff I got wrong. Well, as you can see, there's stuff I got wrong too, for sure. Sometimes it's literally just iteration, right? Thank you for the hydrate redeem, by the way. Got about 20 seconds left on ads. And we're back. So yeah, like there's all kinds of things that I look at, you know, months or sometimes years after I write it, and I look at it and I just go,
What in the hell?
and then you fix it, right? So, yes, I do have a Hank Hill button, and yes, it is useful. It was glorious. So, yeah, that was something I actually added today.
What in the hell?
Okay, so I think what I'm going to do is we're going to, you know what? I don't feel like rewriting all this comment stuff, so I'm just going to copy pasta this. So let's go here. And we're going to say clear. And we're just going to take the buffer. And that's it. So we don't need this. We don't need this. And clears the given buffer. Internally resets the free list if one is used. I suppose we also could have an option here, which is to zero out the memory, right? Because zeroing out the memory is actually kind of an expensive operation, but there are times where you might want to do it. So I'm going to go ahead and add that option just in case we want to do it. Zero memory. True if memory should be zeroed. Otherwise, false. Note, this can be an expensive operation. on large sums of memory. All right. So we have that. Let's go to render front end C. Render buffer free is what we're going to look at because we're going to put it right below that. So put it here. Delete the K API. Change this to a definition. All right, and let's take a look at some of this stuff here. So these are probably, well, this is a valid check, right? If not buffer, right? So let's grab that guy. Obviously, we don't need a size check. Clear. Oh, we still have references to Vulkan in here. What the heck? This should be render buffer, and this one is the same thing. Oh, these are all the same way, aren't they? Okay, I changed that one. Looks like I changed some of them, just not all of them. Okay, render buffer allocate. All right, close enough. Kohi roadmap question, no rush. What's after Rendergraph? Going back to the editor, more advanced UI. Planning more systems, features as multi-threading the renderer. Shader hot reload, PBR. So yes to all of those things. However, next I think I'm going to like scaffold the UI or scaffold the editor a little bit more. And probably do a little bit of work on the UI. But at some point, I really want to kind of step back into the render and add some more render features. Like I want to add shadow maps. I want to add PBR. And I don't want to wait too much longer to do that. I kind of want to have a decent looking engine too. Northland 2, first time chat. Welcome to the stream. May I know what kind of NVim color scheme you have? Yeah, so this is the GitHub dark scheme, I believe. Let's see. Let me do config nvim. I know I have some crap in here for Lightfly, but that's the Lua line. I lied. It's Adawada. I went back and forth a little bit. Adawada is actually what I'm using. I tried like 4 or 5 different themes in the last week, and I couldn't remember which one it was, but Adawada. Sounds like a good plan, yeah. What do I use for UI? Do you mean what library am I using? Or what do you mean by that? I don't need this open. I'm not going to be using any library for it. We are going to be writing our own UI system from scratch. So, stay tuned. Okay, so I guess the next thing that we need to do is probably if buffer how am I checking if I'm using the free list otherwise? Oh, I guess we just look at the free list memory requirement. Okay. Memory requirement equals 0. So we definitely want to make sure that that's not the case. K error. Well, actually, we could clear a memory buffer. We could clear a render buffer, rather, that is not using that, in theory. Not using free list, but maybe needs to be zeroed out. So if 0 memory, to do 0 memory, right? And I'm actually going to do because I don't feel like writing that right now. But I'll make sure that it doesn't like I'll make sure that it doesn't fail silently, right? Okay. So in this case, if we're not using a free list and there is no zeroing of memory, there's really nothing to do. So that could just fall through. I guess I can just say return true, right? Otherwise, oops. Free list clear. So we already had clear in here. So it's really just hooking this up. So it should just be buffer free list. And I think that returns a Boolean. Nope, it returns a void. I suppose, though, if 0 memory, we should also do that here. In fact, you know what? I don't like repeating myself, so let's clean this up a little bit. All right, get rid of this. Return true here. And then actually we can just get rid of this and say not equal to 0, right? So if we're using the free list, clear it. Otherwise, don't. If we have 0 memory, then do the thing. Otherwise, don't. And then return true if everything is successful. Okay, so that should give us what we need. And then in the Vulkan backend, we should then also be able to, let's see, we have begin. I don't think begin is what I'm going to want. No, because that could be within the same frame. Let's see. Is it prepare? Frame prepare, I think. Yes, frame prepare. So at this point is probably when we're actually going to want to do that, right? Because this is where we're checking to see if the swap chain has to be recreated rather. We do our wait for fences and our swap chain acquire next image. This is probably a good place to do it. So we're going to reset staging buffer. And we'll say render buffer clear and context staging. And then for this, we're going to say false. And this actually returns a Boolean. So if that fails for some reason, we definitely want to know about it. Failed to clear staging buffer. Return false. Oh, we need the address of that. Okay, I think that might be everything we need. Now what this does mean is that we're going to be limited to loading basically 256 megs worth of stuff per frame. So we might need to go a little larger on that. But I don't want to go nuts on it either. So let's build. Before we run. Damn, at least you labels will be on the left side of controls. I'm not sure what you mean by that. What do you mean? My labels will be on the left side of controls? Not sure what you mean. All right, let's run this and see if it crashes hideously. Well, something not good happened. Oh, right. We were saying that the... Right, I think I know what that is. I think this is bleating about the fact that we're binding that buffer repeatedly. Name staging, so it is the staging buffer. Attempting to bind, which has already been bound. Right. Okay. So we don't need to do that. Context. Oops. So I think this can be removed. Which actually, yeah, we got rid of the unbind as well. Okay. So let's try that again. Okay. So far, so good. Let's load up a more advanced scene here. All right, I didn't see any errors. Let's blow this up. Okay, so I think we're better off anyway. So I guess probably the thing to do is going to be oh, dang it, I thought I already did this. That's annoying. I might not be able to run another one without rebooting, which would really suck. Yeah, it's set to 1. That's annoying. Let me try... May have to relaunch VTune, but... There we go. That's what I want. Let me just figure out this. All right, let me try relaunching this guy. Okay, there we go. All right, so I'm gonna run this. And I'll load this. And this just gives me a little log over here as well. And I'm just gonna basically do what I did last time and let it rip for about a minute or so. That'll give us a quick feel for how this is running now versus how it's running before. You dropped in mGUI on my stuff, and in this lib, all the labels are on the left side. So, I mean, yeah, theoretically what we're going to do is like none of that stuff is going to be I guess limited. Some of it might be hard-coded initially, but eventually all that stuff's going to be configurable, right? And our UI system I want to make super configurable, right? And it's actually going to be one of many UI systems that we're going to have. And the reason I say that is because if you think about it from a application perspective, the UI needs for an editor application are far different from the UI needs of an actual runtime game. And so those libraries don't and probably shouldn't overlap, right? They should be separate things, implemented separately, used separately, or maybe together, but they should not know or care about one another, right? And we certainly shouldn't be forcing the paradigms of one onto the other. So we're going to wind up with different UI systems. And as we develop those, we'll sort of get a feel for the pros and cons of each, right? All right, so I think this ought to be enough. All right. So if we look in our top-down tree, we should be able to get a much better feel for what we're dealing with this time around. So let's see. Render frame prepare seems to be taking a lot of it, which is interesting. Our render buffer clear is now actually taking a decent amount of time, but let's see. So free list clear is what's taking a decent amount of time, right? But like in perspective, like this is negligible compared to what we were dealing with before. If we look at application render frame and update, like they're much, much, much better off, right? So the reason that this is now heavier is because of the way that we're sort of profiling this, right? So this is just telling us that this is now sort of the heavy lifter in our frame, as it were. And that's not a huge deal, right? I'm reasonably happy with that. That should give us a decent boost in performance. The one thing I didn't think to do was before all these changes, I did not think to actually run and see what our frame rate was before that, right? So we can definitely see that we're utilizing a lot more of our processing power every single frame. But I guess I could go ahead and branch this off. That's probably what I'll do. I'll branch this off, and then we can run a quick test of the main versus this branch and see what, kind of what we get, where we wind up. Before I do that, I'm going to get rid of the dead code. We are not creating that anymore, so that's invalid. We don't need to do this either. Right? Oh, that was only part of our problem, actually, too. So we still had that 22%, actually, I'll bet. So if we take a look at the render frame, so scene pass, execute. Oh, no, these are all draw calls. And instance applications. Okay. Oh, that's right. We're not actually using... that was the other change I had to make. So there was one other place where we needed to do this staging buffer business. So let me grab this. So texture write data was the other place we were doing this, which we're not actually using this yet. So this should just basically drop right into place. So I'm going to put this here. And data is going to be pixels. We're just loading range. I don't think we actually have to do a copy from buffer. Let's see. Where is that actually happening? Yeah, here it is right here. Okay. So this might be a problem. So the Vulkan image copy from buffer only takes the buffer but no offset, no size. So copy buffer to image. Copy region. Buffer offset is 0. Crap. So that's definitely an issue. So I'm going to have to fix that as well, actually. I guess let's go ahead and fix that real quick. So this is actually going to need... I assume that's a U32. Let's see. BK device size, that's actually going to be a U64. Okay, so U64 offset. Offset. I think that's all we should have to add here. So we'll write that. Here we'll say U64 offsets. context type image buffer. Okay, we're actually missing 2 parameters here. So offset, the offset in bytes from the beginning of the buffer. And param command buffer, a pointer to the command buffer to be used for this operation. Okay. And then from here, we have the buffer itself, and then after this we have adds. About 20 seconds left on ads. And we're back. Meborn, random question for the end of the stream if time is available. Was looking at geometry system and trying to understand why the state is being passed into the create destroy static functions. Is there a goal to eventually get rid of the global state pointer? Yes, there is a goal of that. Yeah. I'd like to get rid of most, if not all of those eventually. And I've only gotten partially the way through that. So, all right. So we have this copy from buffer here. And what we did was we just added the staging offset here. And that should do it, right? So this is our new offset that we added here, right? All right, so we have that. We don't need this copy range. We don't need that anymore. So we have our staging buffer, which means that we can get rid of all of this stuff, right? Don't need that. Okay, so we create. Oops, did I get rid of the No, okay, so we're good. So we allocate, we load the range here. And then this is called temp buffer. That's kind of a crappy name. Let's call this temp command buffer so we can tell what the heck it is. And then I'm just going to start shifting these things to a single line when I see them. This should be context staging. And this should be temp command buffer. Right? Okay, so we have copy from buffer, transition layouts, that should be fine. End single use on that. And then we have the unbind to destroy, so we can get rid of those. All right, that should be good. Okay, and then when we're doing a texture read data here, we actually have a different buffer type here of type read, which I think uses different memory flags. So we probably ought to have like a read buffer available for this kind of operation too, with a free list and all that. I'm going to do this because we don't really do this very often right now. It's really only used for the pick pass. So I'm not really too worried about it, but global read buffer with free list like staging, but for reading. I'll just do that for now. Okay, so let me just build this real quick, make sure I didn't break anything. Okay. You know what? I am going to change that that viewport real quick, though. So viewports create. Actually, I think I need the resize is where I really want to look. So what I'm going to do is I'm going to comment this out. And put this up here. I don't remember if that could be zero based or not. I think it can be. That should make it take up the whole screen. So just make it a little bit easier to sort of see the text and everything there. Yeah, that's better. Because we're not using that other viewport in here anyway, right? So might as well just switch this back to how it should be rendering. Okay, cool. So, that is that. Let's go ahead and we'll call this, I don't really have a work item for this. Call this staging redux, I guess. Holy crap, why did it do... I don't know what all this is about. These are the only things that we actually changed. Okay, so git add. Changed staging buffer to be reusable. Redux. And I'm just going to push this to a branch right now because I actually want to do a little bit more testing on it before we actually merge it into main. I did pull this, right? Yeah, I thought I did. Okay. So, you were asking about the geometry system. Which has this state pointer. I think this is what you were referring to. And then we have this create geometry and destroy geometry, which also takes that geometry system state. Is that what you were referring to? Is it because of hot reloading? Yes. So Right now, this is in our engine, which the engine itself is not hot reloadable, but I would like it to be at some point. And so hot reloading is blocked by static data. You can't have static data like that, right? So yeah, that's definitely one reason, for sure. I thought the reload is on the application library versus the engine library. Wouldn't the state data in the engine side, the exe, still be valid? Yes, it would be, unless we hot reload the engine. So, okay, yeah, cool. All right. So yeah, hot reloading the engine was something that I initially had planned, but kind of like boxed myself out from doing that because of this. And a couple of other things, right? Because anytime you hot reload, your static data is invalidated, as well as any function pointers that you have. You have to reset them up, right? Because the addresses will have changed. So there's the things to keep in mind. Yeah, no problem. All right, cool. I think this is actually a pretty decent place to end for tonight, just because we kind of accomplished everything that we set out to do, which is awesome. So let me have a quick look. Let's see who's on that I can raid. Let me actually go to... Let me see who looks like they're doing something interesting. All right, so... You know what? Let's go with Jitspo, because he's making a retro FPS that is looking kind of cool, and I kind of like the direction that he's taking that. So let's do that. Bitewave, thank you for the stream. Learned some stuff. Awesome. I'm glad you learned some stuff. Super glad to hear that. Before I start the raid, I'm going to drop my socials. So this will give you guys places to like follow me and stuff. My YouTube, my Discord server, which we've got approaching, I think, 700 people at this point. So there's always people, talking on there about Kohi and other random technical stuff too. There's a bunch of really smart people in there. My Twitter, my Patreon, all that good stuff. Also, I'll drop a link to the Kohi website itself, which is kohiengine.com, and I'll just bring it up on the screen here just for a second. So this is a website that I set up that has sort of central links to everything that is related to the project. So we have the YouTube and Twitch links here, the Discord server, GitHub. Everything we do here is open source. It is licensed under Apache 2.0, but all of the code that we do here on stream is here. You can see the branch that we just pushed here 4 minutes ago. So that is there for you guys. We also have API documentation. So as we push code, this gets updated, and we can see in here all the various data structures as well as individual files. So if we wanted to look at, I don't know, DArray, for example, we've got API documentation. So this should be automatically updating as we go. So, Neural Freak, first time chat. Welcome to the stream, and also goodbye at the same time. Thanks for being here, guys. I really appreciate it, and we'll definitely catch you guys next time. Let me go ahead and get the raid started for Jitspo here. And his project is looking pretty cool. And so he's using Godot, I believe. And so that's kind of an interesting thing for me to watch as well, because I've not used Godot a whole lot. So it's interesting to me from that perspective as well. And I really like the graphical style of what he's doing. So cool. Anyways, guys, thank you so much for being here. If you haven't already, drop a follow here and or on YouTube. And I appreciate you guys, and I will see you guys next time. See ya.